Yo, what's up? Today we're going to talk about color, specifically in Desmos, but just going through some of the stuff that I've been experimenting with the last few days. Uh, this is not scripted or studied or anything. I don't know everything about anything, but have just been having some fun, and I was just going to share some of this with you guys. We'll also go into how I did the color aspect of the cursed language that was last week's video. All right, so this here is a little gradient that I made. It's using these three colors, and I'll explain how it's using these three colors in a second. Um, but primarily, let's talk about how we plot color in Desmos. So in order to make this gradient, you see that it's made up of a bunch of different points. That's because Desmos can't take like a line and color it a bunch of different things on the same line. You have to break it up. Um, so in order to make that, we have this, which is generated in the line. And yeah, it's basically just giving a coordinate point, which is at height 1. Its x value is given by this, where j goes from 1 to 200, which gives you all these points. So we have 200 points here. And then the tens are just kind of fitting it into this range. And then we have a custom color, which is defined by this, which is a bit gross. Again, we'll get into how that works. But that's what is defining the colors for each of these points. So each time a point is drawn, it goes to the next index in the color and draws that color on the point. So you get this. So if we change, these are randomly generated gradients. You see that the line stays the same, the way it's generated stays the same, nothing else changes. The only thing that changes are these values, which are 3 points. Now these points make up the 3 different colors that we're going to get to. So if you just take the point directly, which is just 3 random values, each one is just a different 3 random values between 0 and 255, we get just 3 different colors if you plug them in directly into, as RGB values, which are these 3 here. As they change, so that these colors, that's what these top colors are. Then what we do is, and I'll show a visual for it for a second, but we're going to use these 3 points to define a Bezier curve and draw that curve through 3D space. We can make it with a more complex Bezier curve by using 5 points instead of 3. So as you'll see, the point that we start at is this color exactly. The point that we end at is this color exactly. However, these 3 colors, you see, you never quite get to that color on that point. Maybe it passes through coincidentally, but these 3 colors do not ever line up exactly with the Bezier curve, at least intentionally. And again, I'll get to why in a second. You can see this is generated the exact same way. The only difference is now we have 5 colors, and we have a much bigger color equation. But again, it's just generating 200 colors based on these random values, and it's creating a gradient through them. So here we've got this box. So with Desmos, it's not very easy to show a 3D cube using a 2D graphing calculator. So what I've done here is I've just made this box 2D square, and then I have the third value, the blue value, being a slider where you can just make it more and more blue as you slide it over. So you can see we have max blue, minimum blue. So over here is 0 green, 0 red, 0 blue, because right now we're at 0. So that's black. If we maxed out the blue and we went to max red, max green, max blue, you get white, which is this corner. And then everything else in between, you can see max green and a max blue, but 0 red makes this sort of cyan. And we get sort of a magenta purple with max blue, max red, and no green. Max green and max red make yellow. And everything else in between. We could even fill it a little bit. Desmos gets really laggy if you try to fill in the entire square, because it's generating a lot of points. You can see wherever I move this point, You can see it's quite laggy already. This box shows the color that we're hovering over for this point. So we can move it towards the more red side. It generates red, yellow. So this is purely dependent on the x and y coordinates, as well as the blue coordinate, which is sort of the z coordinate of this point. So let's move it through sort of the z-axis. You can see we get more and more blue till we're sort of a purple pinkish color. So yeah, so how do we make a gradient? Well, like I said, we're going to draw a curve that goes through this sort of 3D space, this. So if you draw a curve that goes through this box and take the color from each point on that curve and then assign that to each point on a gradient, you get that color gradient. So you see, right now we're starting with black, ending with yellow. We can turn the blue up a bit. You see the gradient becomes more and more blue. As you move this point around, the end of the gradient changes. As you move this point around, you notice that the actual curve does not reach this point. So this would be our middle point of the gradients that we were getting earlier with 3 points. And that's the reason why you don't actually see the middle point show up in your gradient. It's sort of a weight, and you'll see in a second. I have a sort of a visual for that as well. But what this is changing is sort of the middle values, but it's just kind of stretching and scaling it rather than going exactly to this point. So if you want just like a straight curve, this is straightish. You'll notice that as I move this point, nothing really happens visually here. This gets stretched out a bit, this gets a bit denser. You can see here that comes into play a significant amount. You see it's mostly blue for most of the time, and then quickly goes up to this sort of yellowish. Let me reduce the blue value a bit. See it's sort of black to yellow. As I go up here, the actual shape of the curve doesn't change much again. But you see now it's mostly yellow with just a bit of black. You could even go beyond it. So even when you're not changing the shape of the curve, you can still change the way the gradient is drawn based on sort of the weight of the curve. So we'll take one last look at this gradient. Now that we have that context, again, you can see we have our first point on this color, this sort of blue, our second point on this green, our third point on this pink. And we're drawing a line through 3 space from blue to pink. So that's how we make this gradient. And this is actually exactly the same thing, math-wise, as what we did in the previous graph. It's just, we're just not showing the actual curve. Instead, we're just showing the result of said curve and the colors at the points of the curve. So I made a little visual here. In this case, we're going to have our 5 color gradient. Let's say that these 5 colors are our 5 points. So we have like red, blue, green, orange, purple. And so our first point will be red, second blue, third green, fourth yellow, and fifth purple. So now you can see why the middle colors don't line up to the curve, but the first and last colors do. One trend that you'll notice as you do this, let's click this, is that if you take the y values of every single intersection of sort of your t value, is the line that I'm drawing, if you add up all of these y values, you should get 1. So over here, like at exactly 0, this y value is 1, everything else is 0, so we get 1. Then in the middle, it gets a bit more complicated, but we have, in this case, 0.375, 0.248, and there's 2 of them here. So this is basically 0.5 in total. This is, 375. This is 0.06. It will eventually add up to 1 because we have one color that is the sum of a bunch of different weights. And these are how a Bezier curve is drawn. So as you can see over here, at this point, sort of in the curve, and we're drawing points from left to right. So beginning of the curve is over here, the end of the curve is over here. So like at this point in the curve, it's mostly weighted towards the blue point, with a pretty even splits between the red and the green points, and then it's not much weighted towards the yellow or the purple. You will notice that unless you're talking about the exact 0 or the exact 5 or 1, uh, you will find that every single curve has some contribution towards the result. So even as you get like way over here, this first curve has just a little bit of weight still to it. But here's just sort of your visual of how this gradient works. You see over here, as we end up, we get more and more weight towards just the final color, which is why we actually end up at the final color at the end of the curve, with a little bit from the penultimate color and not too much from anything else. So moving on to some fun little projects I've been doing the last couple of weeks involving color. Earlier, I was showing you the RGB valued colors, but there's another way that you can represent color in Desmos, and that's with HSV values, which stands for hue, saturation, and value. And that's, if you've ever seen sort of one of these color wheels, that's where we get that from. So what you can see is the hue and saturation with this wheel. So depending on how far away from the center it is, kind of defines the saturation. And how where you are around the wheel represents the hue. So if you have a hue angle of 90 degrees, we get sort of this greenish color at max saturation. And finally, we have a slider for value, which is sort of the darkness. You can see down here, it's kind of hard to tell what the colors are. So I made a little game out of it. So you can hover your point somewhere around the circle. What you're trying to do is match this color, which is the color that your point's hovering over, to a randomly selected color. So this seems sort of like this, maybe with a bit less of value. Let's see. Try to line this up without taking forever. Maybe a bit more value than that. That's not great. I've definitely done better on this seed before, but I'm going to hit this button to confirm our answer. Did that work? I can't tell if that changed, but let's see. Let's do another one. Make it a bit more bold, a bit darker. Not bad. There you go. And now we have a different color. And we could just keep that going. The grays are where it gets kind of hard. But yeah, you can see how that works, and you can play it for yourself. The links will be in the description. Not bad. So what you can see here is we have a total score and a round score. The round score is how good you were in the previous round. So with that gray that I just did, I was 98% accurate, about. And the total score is just the total score. So every round score is out of 100. I did 3 colors there, so this is 276 out of 300, which is the max score. So not bad. If I'm like way off or something, let's make this like black. Score 47, not great. Although this one, 93, not bad. So here's a little quote unquote ray tracing. I call it ray tracing. It's technically the same method as ray tracing, but just very simplified because this is a very simple object. But yeah, basically we're defining a color that has a certain brightness based on the cosine of its angle with the source of light, which in this case is just us going straight forward. So as each sort of panel turns away, that value gets lower, and so we get less bright. And as it goes behind, it disappears for a bit, and then comes back and gets brighter before getting its brightest when it's right in front of us, and back gets darker again. And this is how we make sort of a 3D-esque shape. Here I have a little sort of 3D plotter, if you can call it that, that I made in Desmos. Again, you can see there's a series of points, and each point is assigned a color. We sort of have, in this case, this is still a gradient, and it's actually derived the same way as what we saw earlier. We have 3 points, and we're drawing a Bezier curve through those 3 points. to draw this gradient. But this time, we're also assigning z values to every single point for x and y, which is how we generate 3D functions. And what we're doing is comparing that z value to the colors on this color map, where and I have to think about this, I think the lower z values are assigned to the lower values on this color map, and the higher z values are assigned to the higher colors. So you see these red points are low points, and the white points are high points. But we could change what that color map is, and it will change. Like, let's make this 0, so we get yellow. That looks kind of ugly. Let's make this just red. That's hard to see. So we make this black. And there we go. Let's add a bit of blue in here to make it like purple. 150. Get sort of a purple and black thing. You see the high points are again in purple. But this is for any function of z that you can think of. So right now I have it this. I also have a little zoom, so you can zoom in. It's very quick. And you can zoom out, which then becomes negative, so you're zooming in again. You get sort of this repeating pattern until you've zoomed in too far, and then you can't see anything. I also have this, which moves the sine graph. So you can see in this case, the y values are being shifted. So we're moving up. And yeah, that's another great use of color, using color maps. If you've ever taken like a Calc 3 class or something, you've probably seen something like this. I just made it in Desmos. All right, so here we have the same sort of square of color that we saw before, where we have red as the x-axis, green as the y-axis, and we have some mysterious blue, which is the z-axis, which we have defined over here somewhere. Here is how I did the conlang color, and hopefully this really gives you an idea of actually just how cursed and annoying this is. So what I was showing you earlier is that you can draw a Bezier curve through 3D space and assign each point on that curve a color, and then draw that color into a gradient. So I did the same thing here, except I made the Bezier curve weird. So here we have each point has an x and y value, so it's a red and green value. And then we also have a blue value for the color, which I will tell you how I defined in a second. But for the red and green values, these first 5 points look like this, in the order there. And when that draws a Bezier curve, it's going to draw an L, because we're going to start here and curve up to here. And that gave me this. That gave me lol. So we drew the L, the O, and the L. Before we applied color to it, we just sort of have this shape. And the shape is being splatted onto coordinates inside this square, which are therefore assigned to color. So then what I did is I assigned a blue color, which you can see over here. And as the point goes from 0 to 255, or sorry, from the beginning of the L to the end of the L, of the second L, the B values start at 0, go to 255, and then also oscillate back and forth. So that defines how blue our color is. So it's a very simple sort of algorithm in this case. We're just oscillating, we're not doing anything fancy. But what that means is, if you can think about Z being sort of the depth, is that we start sort of at the top layer here, and then we dip down as we go down, and we come right back up the end, or I think we dip all the way down at the end. So if I redraw these colors onto here, you can see that we have very little blue here, and you can see very little red and green as well, so it's a pretty dark color. But then we move through the L and we get more and more blue. Still not much red, but a little bit of green as well, so we get sort of that cyan color. And we get sort of a darker red because we get very little green, very little blue, and then becomes more and more red till it's pretty darn red. When we take all of this and then spread it out so it's just a single line, we get this line right here. So again, you can see we're starting from this point in the L, which is right down here. It goes up, gets bluer. We hit the top of the blue right here, and then it kind of jumps over to this point, and then it goes up and up and up, and then we get back to here, which is at the end of this O, and then we go to the end of the L. Meaning that about this point right here, the very beginning of the O, is almost exactly the same color as this point, because that's the end of the O. They're not quite exactly the same color, because like I said, they stop, one away from each other. See that little gap there, but they're extremely close. You can see this little gap down here too. And these are at two entirely different parts of the graph. So if you're trying to do order from this graph, a letter that is colored somewhere down here will be less than a letter colored somewhere like up here, and maybe one here. But as you measure which one's higher, this one looks like it's lower than this one because it could also be this. But if you're very specific, this does not actually lead to ambiguity. Every single color on here is unique because it has a unique X and Y value. And even if it didn't, there's a good chance it would have a unique blue value as well. So yes, so every single color on this graph is different from every other color. So there is a specific order that you can put your words in based on color. But holy cow, it's confusing. So hope that explains it. It's kind of a lot, and not a super long amount of time, but yeah, just kind of off the cuff. Thanks for watching. Lol.